Good morning, students. In this session, we are going to discuss about introduction to push-down automata. Previously, we discussed about finite automata and we have seen many topics related to finite automata. Why we are going from push-down automata even though finite automata is there? Because finite automata has many limitations. Many limitations are provided in finite automata. One of the major limitations is memory. Finite automata doesn't have memory. It works only to process the input. We cannot perform any comparison operation in finite automata. We cannot perform any comparison operation in finite automata. Okay, these are some of the major limitations in finite automata. That's why we are going for push-down automata. In push-down automata, the memory, it has memory in the point of stack. The push-down automata has memory in the point of stack. When I'm speaking about memory, so I will give you an example. If I am asking just with a small input 2 plus 2, so you can answer immediately with 4. Okay, because 2 plus 2 is small input and we can answer immediately. So actually, we have frequently used some smaller inputs which is already stored in the cache. Okay, but when I'm asking some huge inputs, for example, 1,22,345 plus 2,324, what is the addition for this two things? 1,22,345 plus 2,22,346. So we cannot perform this addition within a milliseconds. Okay, why it so means? Because we need memory in order to process these huge inputs. Okay, so that's why we are going from finite automata to push-down automata. Push-down automata has memory in the point of stack, so that we can perform many comparison operations in push-down automata. Comparison operation in push-down automatas. Okay. So when I am speaking about the components of push-down automata, there are three components in push-down automata. First one is tape. Second one is finite control. Another one is stack. Okay. So the tape indicates the user input along with the blank. User input along with blank. So blank is nothing but in order to indicate the end of the user input, the blank will be specified. So blank can be mentioned with capital B. Stack is the memory that is used by push-down automata. So which contains two operations. One is push operation, another one is pop operation. And inside the stack, we will be having an initial element called Z0. We will not be making the stack as an empty in the initial. So definitely stack will be having some element. So one element, that is the initial element, that is Z0. So the input will be processed by push-down automata by using this tape as well as the stack. Tape is just to process the input. Stack is to compare and to perform the operation. So the operation between the tape and the stack is performed by the finite control. Okay, it is performed by the finite control. The state transitions, moving the input from one state to another state, and performing the push operation and pop operation with the help of the stack, and to transfer the states for the push operation and to transfer the states for the pop operation is performed by the finite control. Okay. So when we are speaking about the definition of push-down automata, like finite automata, it also has some combination of tuples. In finite automata, we will be having 5 tuples. In push-down automata, we will be having 7 tuples. Okay. So the tuples are capital Q, tau. Additionally, we will be having 2 tuples. One is tau capital Q tau, then summation del, then Q naught, then Z naught, then capital F. So you already know that capital Q means number of finite states. What are all the states we are using in an automata diagram? That will be coming under capital Q. Tau represents the input symbols. Input tape symbols. Input tape symbols. You can ask me one doubt that why we have to mention tau separately for mentioning the input tape symbols, because our tape symbol contains blank also. The summation will be just input symbols. The summation will be representing just the input symbols what the user is giving, but the tau will be represented with input symbols along with the blank. Then del is the operation what we are going to perform, either the transition table or transition diagram. So that is represented with del, and Q naught is the initial state of the automata diagram, initial state of the push down automata. Initial state of the push down automata. And Z naught is the initial stack element. Initial stack element. Capital F is the final state of the push down automata. Okay. So now you can see here 7 tuples are there in push down automata. In addition to finite automata, we are having 2 tuples. One is tau, another one is Z naught. Tau is nothing but the input symbols, input symbols along with the blank that is mentioned in the tape alphabet, and Z naught is the initial stack element that is mentioned in the stack memory. So you can see here, this is the structure of the push down automata. So this is the input tape. Okay, for example, if I am giving the input as A, B, okay, A will be mentioned here, B will be mentioned in this cell, again A will be mentioned in the cell B, and in order to indicate the end of the input, blank will be mentioned in the tape symbol. So finite control will be here, and in order to represent the stack will be mentioned here. The initial element of the stack will be Z naught. Okay, so the finite control will be having 2 pointers. One pointer will be pointing the stack memory, and one pointer will be pointing the tape symbol. Okay, so this is about the introduction to push down automata. In the next session, we will be discussing about how the moves can be expressed or represented by using push down automata. Okay, thank you.